7.6 example 1. So there's 4 different quadratic functions here that we want to graph. So the first one's y equals x plus 3 squared plus 1. So vertex form. In our introduction here, we said that our p and our q identify our vertex. So right now I know this one. This is my p value, but opposite sign. My k value is the same sign. So my vertex here, p comma q, is going to be -3 and 1. So that's where this graph is starting, -3 and 1. It's opening up, and we know there's a y-intercept of whatever your q value is. So that's what we learned before, but that was only when our p-value was a 0, and our p-value is -3 now. So we don't actually have a y-intercept here that is going to be your q value. It's just your vertex form that we're in. So when we can identify our p and our q, we're in vertex form. My a value is a 1 and it's opening up. So to find our other points, we can just use a table of values. So I'll make a little table of values for green here. You can also graph these on your technology with your graphing calculator, but you want to be able to know how to show your work when that's asked as well. So x plus 3. So if, again, for our vertex, I'm plugging in a 0 for my x to find your y-intercept. When my x is 0, plus 3 is 3. 3 squared is 9, plus 1 is 10. That's not on our grid, so I'm not going to start that large. I'm going to start picking some negative values for x, since I can see my vertex is on the negative side of my x-axis as it is. So let's say on the other side of -3 is a -2. When my x is -2, -2 plus 3 is 1, squared is 1, plus 1 is 2. So when my x is -2, my y value will be +2. When my x is -1, -1 plus 3 is 2, squared is 4, plus 1 is 5. So when my x is -1, my y value is a 5. And this goes with plus or minus. Sorry. No, it doesn't. When it is, we have those other transformations. Those are just our negatives. On the other side of the vertex is a -4. When my x is -4, -4 plus 3 is -1 squared is 1 plus 1 is 2. Now we can start to see our shape of our parabola. And -5 plus 3 is -2 squared is 4 plus 1 is 5. Here is our parabola. That was our green one. Let's do B in blue. So in vertex form here, P and Q identify our vertex. So opposite sign. So my vertex is going to be +4, same sign for Q, +4 and -2. 1, 2, 3, 4, and down 2. So here's my vertex of this graph. I can already predict it's opening down because my a value is a negative. And I know it's going to be a little bit wider because my a value is in between 0 and 1 from our notes previous to this video. Again, we can use our table values to find exact ones, but once you start to see the shape, it's just a matter of picking 1 or 2. So I like to start, once I've identified my vertex, I like to pick points around the vertex so that you can see on each side. So if my vertex is at 4, let's pick 3. When my x is 3, what's my y going to be? So 3 minus 4 is -1, squared is +1, times a -1/2 is -1/2, minus 2 is -2.5. So -2.5. Similarly, on the other side, when my x is 5, 5 minus 4 is 1. 1 squared is 1. 1 times -1/2 is -1/2. Minus 2 is -2.5. We know that there's an axis of symmetry here, so it should be symmetrical on both sides. That's a valid prediction that we can be making. Now when x is 2, 2 minus 4 is -2. Let's write some of this out to help us. So negative 2 squared is going to be 4. Positive 4 times negative 1/2 is going to be a negative 2 minus 2 will be negative 4. 2 and negative 4, which means over here when it's 6, it should be negative 4 as well since it's symmetrical. We can see it's opening down like we predicted and a little bit wider than our original one due to our a value being between 0 and 1. C. Our vertex is negative 1 and 2. Opposite P, same Q. Negative 1 and 2 is right here. My a value is a negative, so I know it's opening down. It's a negative 2. It should be a little bit narrower than our original. And again, I can use the table of values to plot some points. So I've identified my vertex. Again, some good starting points for your table of values is on each side of that. So I'm going to pick when my x is 0. When my x is 0 in this equation, 0 plus 1 is 1 squared times 2. 1 squared is 1 times 2 is 2 plus 2, or sorry, times a negative 2. I missed that. 1 squared is 1 times negative 2 is negative 2 plus 2 is 0. So 0 and 0 for that one. On the other side would be negative 2. When x is negative 2, negative 2 plus 1 is negative 1 squared, which is 1 times negative 2 is negative 2 plus 2 is 0. Again, because it's symmetrical on both sides. We'll try when it's 1. 1 plus 1 is 2. 2 squared is 4 times negative 2 is negative 8 plus 2 is negative 6. And negative 3 should be negative 6 as well because of symmetrical. So negative 3 plus 1 is a negative 2 squared is 4 times negative 2 is negative 8 plus 2 is negative 6. So yes, it does match that on the other side. And black. If you don't have a Q here, so we don't have anything plus, it's always going to be a 0, right? Anything that we don't see is really a 0 added on. So my vertex for this one is a positive 4 and 0, P and Q. Table of values. Some predictions ahead of time. My A values are positive. This one should be opening up. It's a 3, so it should be even narrower than my red one. And our vertex is at 4 and 0. So again, picking some points around 4. So let's say 3. When my x is 3, 3 minus 4 is negative 1 squared is 1. 1 times 3 is 3. So it should be at 3 and 3. Now I can predict based on symmetrical properties. When my x is 5, it should also be at 3. But let's put that in and double check. 5 minus 4 is 1. Squared is 1 times 3 is 3. Let's do one more. Let's say 2. 2 minus 4 is negative 2 squared is 4 times 3 is 12. And then it will be 6 and 12 as well on the other side. So 12 is way up. We can't actually see that, so we know it's going to be narrow. Quite skinny through that point. So it is narrower than our red graph. Now the opposite type of question is example 2, where we need to come up with the equation when we're given the graphs. So that's where vertex form is very helpful for us. So graph A, it's marked here, so that's this one. Graph A is opening up. It's not really narrow or wide, it's around the same, but we'll have to solve for A just to see. And our vertex is right here, which is at 0 and negative 3. So I know for sure that it's y equals some a value, x squared, or x plus 0 squared, and negative 3, so minus 3. Now we have to solve for our a value. So how to do that, I'll do the work underneath here. How to do that is we pick any other point we see on that graph, plug it in for x and y, And already having our vertex plugged in, we solve for our a value. So a point that I can see very clearly would be here, which is 1 and -1. So my y is -1, solving for a, when my x is 1, my x value of my vertex is 0, and my y value of my vertex is -3. So -1 equals a times 1 plus 0 is 1 squared minus 3. So let's add 3 to both sides. So I have 3 minus 1 is 2 equals a times 1, which is just a. So my a value in this equation is a 2. So it's a little bit narrower, not much, and it is a positive because it's opening up. So my final equation that I would write for this one is y equals 2x squared. I don't have to show that 0 if there isn't one, minus 3. B is down here. So I know my a value is going to be a negative value. My vertex is at 3 and -2. So I can write in y equals some a value x. It's positive 3, so it's going to look like -3 squared minus 2. So again, same thing. Let's do our work for our a value of our b function. Y equals some a value x minus 3 squared minus 2. And I'm going to plug in a point. So a point that I can see would be right here. It can be any point that you can see exact, which is 2 and -3. -3 equals a times 2 minus 3 squared minus 2. So adding 2 to both sides, I have -1 equals a. 2 minus 3 is -1 squared, which is just 1. So my a value is a -1. So for a final answer in red, y equals -1, or just negative, x minus 3 squared, subtract 2. These red ones are our final answers. And for blue, for C, it's opening down again, but it's wider, so I have a feeling my a value is going to be a fraction of some sort. My vertex that I can see on this one is right here, which is at -3 and 4. So now I'll have an x plus 3 squared plus 4. To solve for our a value, I need an exact point on that graph. One would be right here, which is -1 and 2. So if my y is 2, what's my a value? If my x is -1 plus 3 squared plus 4. Subtracting 4 from both sides, I have -2 equals a times -1 plus 3 is 2 squared, which is 4. Divide by 4, -1/2 equals a. Y equals -1/2 x plus 3 squared plus 4. That's how we can find our equations when we're given our graphs. Simply look for the vertex, put that in for your P and Q, pick another value that you can see on each graph, and solve for your a value.